So here are your notes on the ends of gas laws. And I'm sorry that somehow they didn't get made, but hopefully this helps to clear some stuff up. So we're going to do them short sections, so they're little videos. The first thing is molecular effusion and diffusion, and it just talks about connections to kinetic molecular theory. So, ooh, sorry. According to kinetic molecular theory, we know that there's an average kinetic energy, which is 1/2 mass times velocity squared. And remember, this is only an average, so basically they take all the particles, they take all their speeds, all their masses, and then this is the overall average. And again, that means that the hydrogen gas is going to have the exact same average kinetic energy as the krypton gas. The hydrogen gas is going to have to be moving a lot faster because, as you can see, it only has 2 grams per mole versus the krypton, which is about 84 grams per mole. But as long as they're at the same temperature, they're going to take up the same volume, they're going to have the same average kinetic energy. And again, just you always want to remember that that means if they're at the same temperature, the lighter gas has to be moving at a higher velocity to make this equal each other, the 1/2 mv squared. You can also actually calculate a root mean speed, and it's a little different than average velocity. It's just kind of showing you kind of on average how fast I think the gas is moving. And it has this lovely little u right here, and it just equals the square root of 3r. You have to use the 8.314r because of the way it's been determined. Temperature is obviously in Kelvin, and then over your molar mass, and it's in kilograms. And again, this is just a rough estimate of how fast overall the gas is moving. And again, if you had a sample of hydrogen and a sample of krypton, hydrogen's root mean square speed would be faster than krypton's root mean square speed. The next slide is just a picture showing you the different ones, and you can see these are all gases at the same temperature being told, and they're showing you the molecular speed. So oxygen is the heaviest gas, and you can see its average speed is the slowest. Nitrogen is slightly smaller, and the speed gets faster. Water vapor is smaller, gets faster, and then you can say helium and hydrogen are significantly smaller, and you can see that their average speeds are much faster. You can still see that even hydrogen has some molecules that are hardly moving, and you can see that it has some molecules that are moving much faster than the average. But again, overall the trend is lighter gases at the same temperature move faster. And then the one calculation is just what's the root means square speed of a certain thing. So we have the 3, which is part of the equation, r, which is 8.314. I took my temperature, 25 degrees Celsius, and I turned it into Kelvin. And then all I did is I made sure that I took my molar mass and I put it in kilograms. And then this gives you your root mean square speed in meters per second. And again, here I'm just showing you that, remember, helium is 4 grams per mole, and that's where I got that 0.004 kilograms per mole. So that's not really to confuse you or anything. So we'll stop there, and that'll be the first section. And like I said, I'll send a couple short videos, and hopefully that works for you.